Though its appearance suggests otherwise, this is actually the most recent portfolio item I created during my time at the Art Institute of Los Angeles. The primary goal of this project was to construct a 2D grid containing blocks and an AI that would then manipulate those blocks in accordance with its preferences about how they should be arranged. The AI in this video prefers a flat block arrangement. The more ambitious goal was to create multiple types of AI with different sets of preferences. Sounds simple enough, right? What made the project challenging were the secondary goals I set for myself. The first was that the AI's finite state machine would be priority driven. That is, each state would have a level of priority or urgency associated with it. At a given time, the most urgent state would govern the actions of the AI. This means that no state could explicitly set any other state. The urgency of each state would fluctuate based on variables important to that particular state. Some of these variables included the topography of the surrounding area, the type of currently active state, and whether the AI was holding a block. Adjusting urgency fluctuation of states to achieve the desired result proved to be especially challenging. Another of my secondary goals, and perhaps the one that complicated the project the most, was that the AI could have no knowledge of the structure of the grid outside of its vicinity. Because the preferences of the AI pertain to the arrangement of the blocks in the entire grid, and not strictly those local to them, this greatly complicated the task of programming the AI. The bare bones of the rendering assignment for this project were already set up by a professor, though I had to refine them considerably. This was so that more time could be spent on the interesting part of the project, and I won't spend any more of your time on it for this reason. Or on the UI, since it was relatively straightforward to build, though I did build it from scratch. I also set out to minimize the likelihood of the AI becoming stuck in the sense that it was immobile and inactive, but also in the sense that it was stuck in a behavioral loop. The architecture of the code for this assignment wasn't particularly difficult. The methodology behind the construction of the more sophisticated finite state machine, however, was a challenge, as was the more obtuse task of figuring out how to realize the AI's preferences. The stuck in behavioral loop prevention also proved to be a bit difficult to pin down. Ultimately, though, I was able to achieve all of my goals, except for the creation of additional types of AI. Though the system I designed allowed for easy exploration of this goal, I was unable to come up with a secondary AI model with a clear and deliberate set of preferences within the time frame. As with my other portfolio items, the source code for this project is available upon request. Cheers.